Hi everyone, we're going to be talking about solving exponential equations today, definitely at the level that you would in IM1 class or more at like an introductory level. So we will talk about powers and exponents and how to solve for a variable if it is the exponent in an equation. First, we need to talk about the equality of bases property. Now, it's going to be kind of a lot of words and definition, but then when we get to a real example, it might become a little clearer. So our equality of bases property says that if b is greater than 0, b is the base. That's the number that's raised to an exponent. And b does not equal 1. So essentially, it's some positive number that's greater than 1. Then we know b to the x equals b to the y. We know that's true if and only if x equals y. So let's talk about what that means. If this statement is true, then x has to equal y. Well, look where x and y are. Those are the exponents. So all this is saying is if you have an equation that looks like this, it's only true if the exponents are the same. So let's just write real quick like a real example that you might see. If I have 3 raised to the x and I said that equals 3 to the third, well, that's only true if these two exponents are the same. So I know just based off this and this property that x has to be the same as 3, or we would say x equals 3. So in order to solve these equations, we're going to have to become really familiar with how to rewrite really big numbers as phrases that look like this. So some base raised to an exponent. So in order to do that, we're going to fill out our table real quick just to refer back to in case we forget what those powers are. So I'm going to fill out a few with you, and then I already have the other end of the table filled out just for time purposes. So what we're going to do is we're going to take this base on the left side and we're going to raise it to each of these exponents. So 2 to the first is 2, 2 to the second power is 4, and 2 to the third is going to be 8. And then I'll show you the rest in a sec. Same thing with 3, 3 to the first, 3 squared, and 3 to the third. Let's do it with 4. 4 squared is 16. 4 cubed is 64. And then for 5, we've got 5, 25, 125. And last one I did is 6. You obviously don't have to stop here, but we're not going to have a ton of numbers bigger than 6 for our base. So this is 6. 6 squared is 36. And 6 to the third is 216. So if you fill out the rest of the table, these are those values raised to each one of those exponents. And again, you don't have to have these memorized, but it's nice to have a table to refer back to when we get to the rewriting step, which will make a little more sense in a second. All right, so you can go ahead and pause that if you want those filled out. You can fill your table up as much as you want. When we are solving these equations, we're going to follow 3 main steps. The first one is that we want to isolate that base and exponent term. So I only want that to be on one side of the equation. In order to do that, there are 2 things that you may need to do. This is kind of like going back to multi-step equations. First, you would undo addition or subtraction. And after that, if that's done, then you would undo any multiplication or division. So it's good to just get these steps down, then they will make a lot more sense when we try them out. Okay, once we have isolated the term that has the base and the exponent, there's nothing else on that side of the equation, then we want to rewrite the other side, so the large side, as I like to say, or the bigger number. We want to rewrite it to make it look like that exponent and base term, okay? The last step is to set the exponents equal to each other. That's basically what we did right here. When we said, okay, if this is true, then x equals 3. That's this last step, setting the exponents equal to each other. So let's try them out with these 2 examples right here. Let's use these steps, and I will zoom into this first one so we can start. Okay, so I've got 5 times 2 to the x equals 160. So the first thing I want to do, step number 1, is isolate the base and exponent term. That means this term right here. I want this to be the only thing on that side of the equation. So I need to undo any addition or subtraction that's happening. I don't see any, so I can skip that. The next thing is to undo this times 5. This is 5 times this value. So in order to undo that, I'm going to divide by 5. And so on the left side, I have 2 to the x. And on the right side, I have 160 divided by 5, which gives me 32. Okay, so step number 1 is done. Step number 2 is to rewrite the large number, that's 32, as the base from the other side with an exponent. So I want to rewrite 32 so that it looks like 2 raised to an exponent. Let me show you what I mean. So I want to rewrite this as 2, and then I want to write the exponent that makes this true. So let's look at our table. This is where this comes in handy. And let's find 32 on our table. Let's see, right here. So if I want to rewrite this as 2 to an exponent, I need to write it as 2 to the 5th power. So that's how I use my table, like that. So let's zoom back in, and I'm going to write that exponent of 5. So that's step number 2. Step number 3, set your exponents equal to each other. If 2 raised to the x equals 2 to the 5th, well then those exponents have to equal each other. So our final answer is that x has to equal 5. Sorry about that, guys. My light turned off. So x equals 5. All right, next one we have 7 times 3 to the x equals 63. So again, I want to isolate the base and exponent term first, and then I want to rewrite it and then solve for x. So I need to undo any addition or subtraction. I don't see any of this problem. So I'm going to divide by 7. I've got 3 to the x equals 9. So this is my rewrite step. I want to write 9 as 3 to some exponent. It's going to be squared. So that means x has to equal 2. These next few problems are really just going to follow these same steps over and over. So I'm going to do some, and then I'm going to have some prepared with the answer for you. All right, moving on to the back page. I think I'll do the left side, and then I'll have the right prepared for you. Okay, so number 3, same steps as before. We're going to divide by this number. I want to isolate 2 to the x. Okay, so that leaves me 2 to the x equals, and then 64 divided by 4 is going to give me 16. So I want to ask myself, okay, how can I rewrite 16 as 2 raised to a power? If I look at my table, it looks like 2 to the 4th is going to be 16. So I now have an equation that I can use my equality of bases property to say that x has to equal 4. All right, here's another problem very similar. I'm going to show you the answer in just a second, so go ahead and pause if you're going to try it. And here is your solution. You should get x equals 3. Just make sure when I do these problems and you want to try them on your own, just pause and then play when you're ready. Okay, next problem, very similar. These will get repetitive after you get the hang of this. I'm going to divide by 2, divide by 2. So I have 9 to the x equals. If I do 162 divided by 2, that gives me 81. And you may, after a few problems, start to recognize, hey, I know 81 is 9 squared. So you know that x is going to equal 2. If you can start recognizing that and not having to write the next step, that's totally fine. I'm going to write it just for consistency. So this is 9 squared, and our exponents have to be equal. So x is going to equal 2. You're going to find that x equals 2 is a solution for a lot of these problems. That wasn't on purpose. That just happened to be. Okay, my tip for you on this one, go ahead and try it on your own. So pause it if you want to try. And then my tip to you, if you need it, is to think of your values separately in your fractions. So when you get to the point where you need to rewrite it, think about how 7 raised to an exponent gives you, some number, and 2 raised to some exponent gives you some number. So try it out. And here is your solution when you're ready. So when I get to the point where it says 7 over 2 squared equals and then some fraction, I took a look at the numerators and the denominators separately. And I know that 7 squared gives me 49 and 2 squared gives me 4. So the exponent had to be 2. All right, next one. Ooh, we're changing it up just a little. So this time, the term that I want to isolate is right here. It's 6 to the x. And I have this divide by 4 that I don't want. Notice there's no parentheses. So this divide by 4 is separate from the 6 to the x. So that means I want to multiply both sides of the equation by 4. So if I do that, I've got 54 times 4, and I have 216. So taking a look at your table, we definitely have that number. This is going to be 6 to the third if we replace this. And that means that x has to equal 3. All right, next one. I have the solution ready for you, so go ahead and pause if you want to try it. And here is your solution. So it looks like when we take 1 over 9 and we square it, it's going to give us 1 over 81. All right, one more that I'm going to do live with you. It's this problem, nice and long. This is a good challenge one. So I've got 1/4 and then 5 over 6 to the x. So again, just because this one's a little tricky, I'm going to highlight the entire term that I want to isolate. So if I've got a times by 1/4, that's like dividing by 4. So I'm going to multiply both sides by the reciprocal in order to undo this times by 1/4. So I'm going to multiply this by 4 over 1, and I'm going to multiply this by 4 over 1. So on the left side, all I have is 5 over 6 to the x, and on the right side, I have 300 over 432. Now, you may notice that these numbers are not on the table for 5 and 6. So that is my clue to simplify this fraction. I want to rewrite this so that they do have multiples of 5 and 6. So if I do, I find that 300 and 432 are both divisible by 12. So let me rewrite that in another color. So I'm going to divide the numerator and the denominator by 12, and if I do that, I'm going to have 5 over 6 to the x, and then this is going to be now 25 over 36. So same fraction, just smaller numbers. All right, now we can see that 5 squared is going to replace 25. So let me rewrite this side. So 5 squared and 6 squared. So that means we're squaring this fraction. So x equals 2. All right, last one, very similar, definitely a more challenging problem. Try it out. I know we love our fractions. Go ahead and pause it, and then I will show you the answer. So very similar steps to before. All right, thanks so much for watching, guys, and this worksheet should be up on my website soon.